linear systems of equations in matrix form. In this video, we're going to introduce the notation A times X equals B, where A is an n by n matrix of the coefficients, X is a column n vector of the variables, and B is a column n vector of the right-hand side. Consider the following system of linear equations in two unknowns x1 and x2. We can write the system in a matrix form by defining matrix A to be a 2 by 2 matrix of coefficients. This notation, column equality sign, means that we define A to be this 2 by 2 matrix. We define X to be a column 2 vector of our unknowns, and B, we define it to be a column 2 vector of the right hand side. We can generalize this idea if we have a system of linear equations with n unknowns. We can define matrix A to be an n by n matrix of the coefficients. We can define X to be a column n vector of the variables, and we can define B to be a column vector of the right hand side. This notation is compact and convenient, and we can write these equations at A times X equals B. Notice that we have not discussed the matrix vector multiplication or how even to solve for X. We are just going through the notation for a matrix form of linear systems. Let's look into an example. Here we have a linear system of equations with 3 variables. However, notice that in line 1, x1 is missing, and in line 3, x2 is missing. This means the coefficients for those variables are simply 0. Therefore, we don't write them. However, when we write the system in matrix form, we must include 0 in the matrix so that we can keep the matrix a square matrix. Now let's define A and B in Julia. We've seen this before. We can define A to be a 3 by 3 array and B to be a 3 vector. Now it's time for you to practice. I want you to write problem 1 and problem 2 in the matrix form and define A and B in Julia. Next time, we're going to talk about the matrix determinant.